Hello guys, welcome to our slideshows. Today we will introduce you guys about nuclear reactions, fusions, and fissions.
Introduction to nuclear reactions. Nuclear reactions happen when two nuclei or nucleus and a somatic particle collide and produce new nucleides. This means at least one of the original is transformed into something different.
What is a fission and how it works? What does fission means? Fission means breaks. When a nuclear is very unstable, adding a neutron will catch the nuclear to fission. Fission lets the nuclear to produce two or more small nuclei, which breaks and produce more neutrons, produce a big amount for energy. Two real-world applications. Nuclear power plant. Nuclear power plant is produce heat energy by nuclear fission of the fuel in nuclear reactor, which then requires cold like water, liquid sodium, which then take the heat away from the reactor and carries off to produce the steam. The steam pushes the turbine to rotate, which connects to generator to produce electricity. How nuclear weapons work? The use of the explosives to compress fission material to a supercritical state in initiating a chain reaction, which then provides neutron to initiate the fission reaction. So what is a chain reaction? In a fission, release the neutron that go on to trigger the fission of the other atom nuclei. So what is the pro for the nuclear fission? A small amount of fuel can produce a lot of energy. What is the cost of the nuclear fission? There is a high risk of the accident, and the waste is radioactive.
Slide 5. Nuclear fusions. Let me start by explaining nuclear fusions in a simple way. Fusions is a process where tiny atoms like hydrogens smash into each other and stick together. When they do, they form a bigger atom and give off a high amount of energy. This is actually what powers the suns. But fusions doesn't happen easily. It needs super high temperatures, even hotter than the sun's surface. So the atoms move faster enough to crush and fuse. Scientists are working on ways to create these extreme conditions here on Earth. Slide 6. Two real-world applications. So where do we see fusions in real life? The most example is the suns. Fusions happen deep inside the suns, and it's the reason we have light and warmth on Earth. Now scientists are trying to copy the process of Earth by building fusion reactors. These are machines designed to create fusions in a controlled way, which could give us a new sources to clean energy in the future. Pro and cons fusions. Pro, there are a lot of advantages to fusion. It doesn't pollute the air like fossil fuels, and it doesn't create dangerous long-term radioactive ways like regular nuclear power also the fields for fusions, like hydrogen is super common. But there are also challenges. The biggest one is heat. Fusions need incredibly high temperatures. Also, the technology is still very expensive and not quite ready for everyday use, like powering cities. Still, fusion has a lot of promise. If we can make it work, it would be a game changer for clean energies.
Comparison slide. Fission and fusion. The neutron splits a larger atom into smaller ones, releasing enormous amounts of energy. This is a process that we currently use in nuclear plants, though it produces radioactive waste as a byproduct.
Let's take a look at what's happening right now in the world of nuclear energy and what the future might hold. In fission, there's a lot of excitement around small modular reactors or SMRs. These are compact nuclear reactors that offer more flexibility and safety compared to traditional large-scale plants. Countries like the US, Canada, and the UK are investing in SMR technology to help meet energy demands and reduce carbon emissions. On the fusion side, we have projects like ITER in France and private companies like Helium and Commonwealth Fusion Systems working to make fusion energy a reality. These efforts are focused on creating controlled fusion reactions that generate more energy than they consume. A major milestone we're getting closer to. However, there are still challenges. Fusion reactors need extremely high temperatures, hotter than the sun, and scientists are still figuring out how to sustain the reaction long enough for it to be practical. Personally, I think nuclear energy, especially fusion, has incredible potential. It could give us a clean, nearly unlimited energy source without greenhouse gases or long-lasting waste. But to get there, we need continued funding, innovation, and public support. To wrap this thing up, we talked about two types of nuclear reactions, fission and fusion. Fission is the splitting of atoms and is used today in nuclear power plants and weapons. Fusion is the process that powers the sun, and scientists are working hard to harness it for use here on Earth. Fission is efficient and well developed, but it comes with risk like radioactive waste and potential for accidents. Fusion, while still in the experimental stage, promise safer and cleaner energy. The key takeaway is that both processes have their role to play in our energy future as we face climate change and growing global energy demands.
nuclear science could be one of the most important tools we have, especially if we can make fusion energy reality. And thank you for watching.